Hello everyone. In this video, we're just going to do several examples of how to graph inequalities to kind of show you what's going on in each different type of inequality statement and some of the tricky things that go on, okay? So what I have set up here is kind of a red light, green light deal, all right? We're going to go ahead and start with the greens. They're the most basic inequality statements to graph. Then we'll talk about the yellows and move on to those red ones, which are the, I don't want to say harder ones, but in this case, these are the ones most often missed, okay? And so you go ahead and follow along in your notes if you have those out. This would be truly beneficial to help you study or whatever you need to do for that, okay? So let's go ahead and do the greens. The first thing I like to do in every inequality, no matter what, is read the inequality to kind of get a feel for what's going on. So we're going to go ahead and start at number 5 here. That's the first one, the screen. It says J is greater than or equal to 8. Okay. Now I'm going to have to make some decisions. How can I represent all my possible J's on this number line? Well, I start with the given, 8. J can equal 8, so I'm going to do a closed circle at 8 to represent the fact that J can be equal to exactly 8. Now, what other values can J equal? Now, if I know what greater than is, then I can say, well, all of these numbers to the right are greater than 8, which is great. It saves me some time. I can draw that graph and move on to the next one. If I do not understand that, or maybe I'm just having, a brain fart or whatever, the best bet is to go one number below and one number above your given value. In this case, it's 8, and kind of see which one is true and which one is false. Okay, so we're doing a what if basically. So what if J was 7? Is 7 greater than or equal to 8? Well, we'd find out that that's not true. So it cannot go in 7's direction. What about 9? What if J was equal to 9? Is 9 greater than or equal to 8? Turns out that that is true. So 9 is a possible answer. So all of the ones in the direction of the 9 can happen. Now we do a line because instead of a whole bunch of dots, because we have 9.5, we have 9.2, we have all these other different possibilities in our number line. So to represent all of them, we just do that straight line all the way. Okay, and let's move on to the next green here. I'm going to work this one a little faster now. It says C is less than or equal to -6. So we start at -6. We realize that C can equal -6. So we're going to put that closed circle. And then what values are less than -6? On a number line, all of my smaller values are to the left. So we're going to draw that arrow to the left, nice and bold, so everybody can realize and know that, hey, we're going left. And that's how that one graphs. Moving it on to number 12, our last green here, we have H is less than 13. Now in this case, H cannot equal 13. So we need a nice open circle to represent the fact that we can get as close to 13 as possible, but we cannot reach that point. So what values are less than? Because H is less than 13. All of these values to the left are all less than 13. So we're going to draw that nice line, bold in our arrow, because guess what? Those values continue on into the negatives. Okay. And there's that graph. Now let's talk about the yellows. Now, the yellows are a little, just one level up as far as trickiness, simply because the variable is now on the right-hand side of the statement. You have to remember that the graph represents all of the possible variable values. Okay, so we may read this and we say 8 is greater than s, but this number line has to show me all my possible s's. Okay, so we have 8 here. If 8 is greater than s, what could s be? So again, I'm playing that what if game. So we're starting with 8, so let's do 7. Could s be 7? And reread it again. 8 is greater than 7, you bet. 7 sounds like a great answer, which means 6 would sound like a great answer. 6.5, 5, 6.5, 5, 4.5, all of these values in here would also be true. Just for the sake of it, let's go ahead and try 9. If we put 9 in there, we have 8 is greater than 9. That is a false statement. Okay, so what's going on? It looks like s can be any number that's less than 8, but not equal to it. See, notice there's no equal sign there. Okay. So what we would do is at 8, we would put an open circle, and we'd go to all of these numbers less than. What's the trick here? Well, the trick is you have to read the inequality backwards, or at least learn how to. So if we were reading it forwards, it says 8 is greater than s. So let's put this in relation to s. Well, if 8 is greater than s, that means s is less than 8. And then we could graph it normally. Let's try that trick with this one, number 3. Number 3 says 1 is less than h. Reading that backwards so that we read the variable first, because that is what we're representing in the graph. We say h is greater than 1. That's right. Okay. Now we can graph this a little more easily. So we're starting at 1, open circle, because h cannot be equal to 1. It has to be greater than 1. And all of the values that are greater than 1 head to the right-hand side here, just like that. Okay, let's try that again with 13. So 13 reads 3 is less than or equal to r. So what is r? Well, if 3 is less than or equal to r, then r must be greater than or equal to 3. In this case, r can equal 3, so we're going to have that closed circle. And it needs to be greater, so all of the ones to the right-hand side again. Last yellow. Again, we're going to use that reading it backwards thought process. So 16 reads 12 is less than y. So what is this statement in terms of y? Because that's what the graph needs to represent. The graph needs to represent all of the possible variables, values. Okay. So y, if 12 is less than y, that means y needs to be greater than 12. Okay, notice how that sign has just been flipping. And that's really what's going on here. When we have the variable on the right-hand side, we just flip the entire statement so that now we have the variable on that left-hand side. Okay? All right, let's go ahead and finish this. It says y is greater than 12. We're going to go 12. It cannot equal 12, so we have a nice open circle. And all the greater than values, we're headed to the right of the number line, drawing in that arrow. And let's move on to this red level. Okay, so the red light inequalities. Now, so what's going on here? Well, if you look at all of the reds, you'll notice that there is a negative in front of each variable. That does something rather drastic, okay? And we're not going to really discuss it too much until we're learning how to solve inequalities, because ideally this is not really solved yet. I don't have what z can be. I have what the opposite of z can be, for instance. So we have one more step that we have to accomplish. So let's do this from a graphing standpoint and see if we can understand what's going on. Well, we know we have 1/2, okay? But how do we represent just a regular z? Well, this says the opposite of z is less than or equal to 1/2. So what would z be? Well, it turns out if I have a negative value or negative variable, what I'm going to do, first of all, is kind of switch that around to a positive. Now, what I do to one side, I have to do the other. So if I'm changing it to its opposite here, I need to change the right-hand side to its opposite. So instead of 1/2, we would end up having a negative 1/2. Okay, so let me get a thinner pin here. So we would end up changing the sign of both sides. That's really what we're doing. Now, funny thing that happens is if I change the signs or the value signs of an inequality, the inequality itself also has to change. Okay? So this statement no longer is negative z is less than or equal to 1/2. It turns into z is greater than or equal to negative 1/2. Very interesting. So just to recap what happens, the signs on both sides change and the inequality flips. Okay? And this is a rule that happens in inequalities when we're essentially dividing by a negative, which is what we're doing when we change the signs of both sides. So, okay, so let's go ahead and graph this. We're going to start at negative 5/10. Well, here's 0, so negative 1/2 would be right here. It can be equal to it, so we're going to close it up. And then z is all of the values that are greater than that. So z can be all of those, and that's what that graph looks like. And let's do another red one. Okay, so number 4, again, we have a negative with our variable. What we're going to do is we're going to change the sign of both sides of the inequality. Okay, so d will now become a positive, and then it says -1. Well, then we're going to change that sign to a positive 1. All right, now we're going to flip this flip the inequality right here. So instead of less than, we have greater than. Let's rewrite it. We have 1 is greater than d. Now we're at that yellow stage, okay? And if you remember that yellow stage, we just essentially read this statement backwards. So if we read it forwards, it would say 1 is greater than d. Well, if 1 is greater than d, then all of the numbers that d could be are less than 1. So d would have to be less than 1 here. And that would help us in this graphing. We're going to start at 1. It cannot be equal to, so we're going to have that open circle at 1. And d can be all of those numbers that are less than that. So all of them to the left. All right. Now, if you're starting to get the hang of it, you can go ahead and pause the video, stop the video, and get working on your assignment. But I'm going to keep going with these red ones. They are quite difficult, so I'm going to just do all of them to give us extra practice. All right, number 7. Again, we have that negative variable. When I see that negative variable, I'm going to change the signs of both sides of the inequality. So I have a negative v, that's going to become a positive v. We have a positive 3, so that's going to become a negative 3. When I do that, the inequality also has to flip. Okay? So the statement that we end up getting is v is greater than or equal to negative 3. Turns out the variable is right in front, so this is a green light. We can go ahead and graph this. At negative 3, it can be equal to it, so close that circle in. And v can be any value that is greater than -3, so we're going to the right. I'm going to go straight over here to number 17. We have negative z is less than -2. Okay. Again, we have that negative variable, so we're going to change its sign. If we change the sign of the left-hand side, we have to change the sign of the right-hand side. Again, I'll kind of discuss with the reasonings why here when we're solving inequalities. All right. And last step is to make sure that that inequality gets flipped. So we're going to end up with z is greater than 2. Okay. After we write that down, we've noticed that we do have that green light so that we can graph it. Okay. It's kind of fun how that works. Green light. So the variable comes first. All right. So graphing this, it cannot be 2, open circle, but it can be anything greater than that. So we're going to go to the right, just like that. All right, moving straight up, number 15. Again, we have that negative variable, this time on the right-hand side. So we're going to change the signs of the right-hand side and the left-hand side. So what once was positive now is negative. After we do that, we'll flip that inequality. So our new inequality statement is -1 is less than x. Okay, this is the yellow one. So we're going to have to read this backwards in order to graph it correctly. X is greater than -1. X cannot equal -1, so that's an open circle there. And any number greater, we're headed to the right. Next up, number 14. Change those signs. So P becomes positive and 6 becomes negative. When we change those signs, we're also flipping that inequality. Our new statement is going to be P is greater than or equal to -6. Okay, we've got that green light, so we can go ahead and graph this too. All right, it can be -6, so we're going to just close that circle in, and it can be any value that's greater than -6, which is all of these guys, just like that. Last one, switch up those negative signs. J becomes positive. -2.5 becomes positive. Flip that inequality, and we get 2.5 is less than or equal to, let's do it this way. We get 2.5 is less than or equal to J. Okay, that's our yellow light, so let's read this backwards. So flip it on over. J is greater than or equal to 2.5. The graph for this, we're going to start at 2.5 or 2.5. It can be equal to that, so we're going to go ahead and close that circle in. And any value greater than that, we're moving to the right. Okay, this has helped you understand the different things that could happen when we're graphing inequalities. If you have any further questions, I would be happy to help. Just come on and ask me. Until then, thank you for watching.